This is number 21 of the Chapter 4 homework set. The problem reads, a soccer player kicks a rock horizontally off a 40-meter high cliff into a pool of water. If the player hears the sound of the splash 3 seconds later, what was the initial speed given to the rock? Assume the speed of sound in air is 343 meters per second. From this information, I drew a small sketch. So the V initial is completely horizontal as the person kicked it horizontally, and it travels in this path to the water. And then after, this sound takes the shortest path, so a straight line to the person at a speed of 343 meters per second. And we're given the total time is 3 seconds. First, what we would want to find is the time it takes to reach the water, and we can easily find that using the kinetic equation. V or y position is equal to y initial plus velocity of the y component times time minus 1/2 gt squared. From this, we define 0, 0 to be where the person is, so it goes negative 40 meters in. Starting from 0, the initial velocity is 0 as he kicks it completely horizontally, and it's the only force acting upon it is gravity. So from this we can compute that the time that the ball takes to hit the water is 2.86 seconds. From this we can then compute the time that the sound of the splash takes to reach the person, and that's simply 3 minus 2.86 seconds to give us 4.14 seconds. From here, this gives us the ability to calculate the x component, or the distance that the ball traveled or the rock traveled inside of the x direction, as we know that this distance is a hypotenuse, right? So it's 343 meters per second, the speed of sound, times the time it took, 0.14 seconds, which is 49 meters. The x component, therefore, is the distance of x squared plus 40 meters squared is equal to this 49. This is just the height of the cliff. The distance of x is then 28.3 meters. From here, we can use the x position kinetic equation. The x position is equal to initial x plus velocity initial in the x direction times time 1 plus 1/2 acceleration times time 1 squared. And we simply plug in 28.3 meters for the x position. We defined it as starting out at 0, and the time it took was 2.86 seconds to reach the pond. There is no acceleration acting upon the horizontal component. This gives us the velocity of 9.91 meters per second.